Let me just start by very quickly introducing myself. My name is Placona. I'm a developer evangelist for a company called Twilio. There's some information on the screen about myself. So you can find me on Twitter, you can find me on GitHub. All of the code you're going to see today, some of it's going to be live coded, will be on my GitHub account. So if you want to go and check it out, you can just go there. I also run AndroidThings.rocks, which is a website focused for people like yourselves who want to get started with IoT on Android. There's one last bit of information I want to share with you today, which is basically just hot off the press. I'm also now a Google Developer Expert, so this is like this morning. It was like, I got the confirmation this morning. Thank you. But let me just start by asking, who doesn't know Twilio here? Who doesn't know what Twilio is? Because there's going to be a demo at the end, so it's important that you know. Cool. So some people don't know Twilio. Twilio is a communications API that helps developers like yourselves adding things like SMS messages, voice, like telephone calls, also IP messaging. So if you want to build a chat, if you want to build video, so we have all of the communication tools for you, so you can just go sign up and start using. You can get started for free, so I'm not trying to get you to sign up for anything that is going to cost you money today. But that's enough about me. Now, I want to tell you a little bit about why I'm talking about Android Things here. And the first reason is, well, what is Android Things? Who's been playing with Android Things? Cool. So not many people. So Android Things is an extension to the Android platform. So some of the things you can see here are places where Android has been running. You know, it runs on your phone, it's been running on your watch, your TV, your car. But also, right now, you can run Android Things on other devices. So devices that you couldn't run before. Devices such as a Raspberry Pi, for example, devices that will actually enable and allow you to interact with the external world. Now, some of the examples of applications for Android Things is you can build stuff like cameras, you can build gateways, you can do like points of sales. If you work for like a truck company, you can do asset tracking or fleet tracking. So you can actually have those devices that you programmed yourself inside those things. But the most interesting thing about Android Things, because IoT has been out there for a while, but for me, the most important thing about Android Things is the fact that now you can use those technologies, or you can use IoT, you can build IoT things using the technologies and languages you already know, okay? So I am going to be doing some coding later here, and what you're going to see is, if you are an Android developer, if you've written any line of Android code before, you're going to be right at home here. But where does it run? So I mentioned one of the places where it runs already. So Raspberry Pi is one of the devices where you can run Android Things. And I know some people who know Android Things, they must be looking at these slides here and saying, no, there's something wrong. You missed something here. Stay with me. If this talk was 3 months ago, I would say Android Things runs on Intel Edison, it runs on the Intel JAL, and it runs on the NXP Pico, and also, like I said, the Raspberry Pi. However, something happened, and where does it run kind of became a where did it run, because these two here have been deceased. They don't exist anymore. And the reason they don't exist anymore is basically because Intel decided they don't want to keep running those controllers, okay? So it's nothing to do with the platform. Those devices, they weren't made for Android Things. They were devices where you could run Android Things, but they weren't specifically made for Android Things, and Intel decided that they don't want to be in that particular game anymore. However, what happened was NXP kind of caught up with it, and they launched some more devices. If I was also giving this talk a few months ago, I would say, well, NXP is not really the best option if you want to get started with Android Things, because it was really expensive. Like I'm talking, you know, over 150 euros to actually get an NXP Pico before. Whereas now the prices have gone down quite a bit. And if you look at the first one and the last one, they have the same price. So you could get started with any one of those devices here, and you could be doing Android things. But I'm going to talk to you about my favorite device today, which is the Raspberry Pi. And I'm going to tell you why the Raspberry Pi is my favorite device. First, because it's got an amazing community. If you have any issues with a Raspberry Pi, if you have any issues with the GPIOs or anything, it's very easy to get help. With the NXP, you can get some help, but because they have so many new devices, it's not going to be as easy to get help. The Raspberry Pi has been out there for a long time. It's very easy to acquire a Raspberry Pi as well. You can just go online and buy a Raspberry Pi. It's very easy. It's like buying an Arduino. You can find it anywhere. But the other reason why I really like using Raspberry Pis is because I'm happy with paying 35 euros to put something behind my door, for example. I'm happy with having 35 euros behind my door. I'm not very happy with 150 euros, for example. I'm not very happy to have a device that costs me 150 euros and just stays there. And this is why I prefer using the Raspberry Pi, and is what I'm going to be using today for my examples. However, if you have any of the other devices, you can use my codes because it's going to run the same way. So there's no difference in terms of how things run. It's just how much you're going to pay and what applications you want to use. How do you get started with Android things, though? What do you have to do to get started? So the first thing you need to do is obviously get a Raspberry Pi or get a device. The second thing is you're going to get a memory card. So the memory card is where Android is going to be installed. Much like your phone, much like your watch, this is where Android things is going to be installed. The next thing you need, and you probably already have it, is Android Studio. You don't need to do anything different in Android Studio to run Android things or to program Android things. Nothing different, same thing. Okay, you don't need to make any configuration changes or anything. It's the same stuff. Next up, you're going to get your memory cards over there, and you're going to type something like this on your terminal. This works on any operating system. So I'm doing this on a Mac, but this works on any operating system. You're going to type something like this in your terminal. And what's going to happen is you're going to wait. That is going to take a while. So I usually tell people, like, get a cup of coffee, just go out and wait, because that can take anywhere. So depending on the memory card you're using, that can take anywhere from 15 to 20 minutes to like an hour. Now, when do you know this is done? So what happens like when this is done? You get something like this, okay? So you get a screen like this that says, cool, you are connected to the Ethernet. You can do that on the Wi-Fi as well if you want to. It depends on how you're running it, but it's got Wi-Fi as well. And you're going to get a screen like this. So this is when you know Android things is running. So the OS is installed. Great. Now, instead of like just showing you some more slides, I actually want to do a quick demo here. I have a Raspberry Pi here, which I'm going to try and show you. It's kind of tricky to show with this camera and the lighting as well, but hopefully it's going to work out. So I'm gonna switch to my Android Studio, and I'm going to show you a demo. So you can still hear me, yeah? So I'm going to start from scratch here. So I'm going to create a new Android Studio project, so a new Android project. I'm going to call this IoT demo. And let's just mix this up. Oh, sorry. Great. So let's just mix this up a little bit. So I'm calling this IoT demo, and I'm going to try and do this in Kotlin today. You can do it in pure Java as well, so it's up to you. The one difference you get on Android Studio right now is instead of choosing a phone or tablet project, I'm going to choose an Android Things project. You have different versions here you can choose from. I am going to start with an empty activity, and I don't need UI for this, so I'm not going to be using any UI. I just want things to show on my device. I just want things to happen on my device. And this project is going to load up, and you're going to end up with something like this. So this is your bog standard Android project. And let me see if I can show you what my thing looks like here, if this works. Right, unplug, plug again. Okay, let's close that. So I just want to try and show you what my... It is not showing for some reason. That's okay. Oh, here we go. Cool. So you can now see my device here. I know it's not great, but you can see my device. So the first thing I'm going to do is I'm going to get rid of all this because I don't need these comments. And I'm going to start with this blank activity. On my activity, I'm going to create a new service. And on this service, I'm going to say I'm using the peripheral manager service. So this is an Android Things, this is part of the Android Things library. And what I want to do is, I want to see how many GPIOs I have on my Raspberry Pi. So I'm just really checking that I'm connected to the Raspberry Pi. And let me also connect to it. ADB connect. And now I'm connected to it. Cool. So let's just create a tag here. So log t. And let's create let's just log d. Right, so what I'm going to do now is I'm going to call service.gpio list. And when I install this into my Android Things device here, which is the Raspberry Pi, I'm going to click OK. I'll open my logcat. You see a bunch of things are going to start to happen, and I'm going to leave these as well here so you know I'm not cheating. What you should see at the end when this finishes compiling, so it's building and running now, so when this finishes compiling, you should see that at the bottom here, I will get, let's zoom in a bit. So I get all of the GPIO. So now I have access to all of the GPIO on this. So I have access to maybe connecting an LED, maybe connecting a button, but I haven't done that yet, okay? But this is the very beginning. So this is like, let's see what happens. And we know this works. Great. I'm going to stop that, and I'm going to leave this here for a bit. And I'm going to go back to my slides. And cool, so I had a video here, so just in case this didn't work, I would just show you a video. So I had a backup. We can skip that. But we have been very hardware free so far. We haven't used any external hardware. I know you could see a button here, but we haven't used anything, okay? We've been very hardware free so far. Let me just give you a very quick hardware 101, because if you've never done anything with hardware, you are going to come across this. So obviously, this is the Raspberry Pi I'm using. This is a Raspberry Pi 3, and it's got all these ports here. So anything that starts with like BCM, those are GPIOs. Okay, so those are general purpose input and output. So those are things you can connect to, and you can connect sensors to it, for example, or you can connect stuff like buttons or LEDs or anything. Then the other thing you're going to come across to are these things here. Okay, so a breadboard is basically a place where you can connect all your hardware without having to do any soldering. So when you are just starting with this, you don't want to go and solder something and suddenly you realize you actually made a mistake. Okay, so what you want to do is you want to use one of these because you can very quickly just plug things in and out. So it's very easy for you to move, and then you will also see that you have some connectors here, so you have some cables. So these are just regular cables, and you have resistors, okay? Resistors are basically a way for you to control how much current is actually going into something. So if you have an LED, for example, you can't just send 5 volts to an LED because you're going to burn it. Much like the light bulbs you have at home, like you use 240 volt light bulbs, if you put a 110 volt light bulb, it is going to burn. You're going to see some smoke, it's going to be nasty. The other thing is you have the LEDs. Okay, so I believe most people have seen an LED. You have two sides to an LED. You have a positive and a negative. The one thing I want to make people aware of is when you see these colors here, they actually matter. Okay, so don't just go for the colorful and nice ones like I did once, and they actually matter. Okay, so this is like a way for you to control how much current is actually going to go into something. So the colors actually matter. It's very easy to find on the internet what everything means. And then the other thing you're going to see if you start looking at Android Things examples is you're going to see something like this. Okay, so this is a software called fritzing. It's free. A lot of people use fritzing to show what their designs are or what they're actually doing, how the connections are and everything. So this is especially important if you want to show someone how to connect things up, because it's very visual, okay? And it's very easy, like it's just like you're just dragging and dropping wires. It doesn't test anything for you, but it's a great tool to help you showing or like demoing or even like if you want to teach someone, this is a great tool for you to actually give that information away. But why don't we go ahead and just do another demo? And this other demo is going to be a little bit more, well, not interactive, but we're going to do something with it. So let me go back to my idea here. Cool. So what we've done so far is, if you notice, we have this Raspberry Pi here. There's a button right here, so you can see my finger. There's a button right here. And right now, if you push this button, nothing is going to happen. So let's just see how we can push this button and make something happen. I'm going to start by opening my build.gradle. Like I said, this is pure Android, okay? And I'm just going to do some cleanup here. So I'm going to use a specific version. I'm going to get rid of some of the stuff I'm not going to use right now. And I'm going to add a library that is called button, okay? And this is basically a library that you can use to interact with external buttons, just like this. So unlike the widget button that you get on Android, this is a library for external buttons. And I'm going to say this is version 0.4. So this is on GitHub, okay? I'm going to sync, and hopefully when this finishes syncing, we can go ahead and make some changes here. So first thing I'm going to do is I'm going to get rid of this. I'm gonna create a button here, so I'm gonna create a late init var, and this is gonna be called button, and it's gonna be type button. That's the important bit right here. You have an Android widget button, and you have an Android things button. You wanna choose the Android things button. Great. So let's initialize this button. So button equals button. And I'm going to tell this button which GPIO I'm connected to. Because if you remember, I've actually got some wires connected to my Raspberry Pi. So I know I'm connected to BCM6. And now I'm going to say what action I want when I actually click the button. So I want to go logic state. You have two logic states here. Pressed when low and pressed when high. So pressed when low is like when you push the button, and pressed when high is when the button goes up. So let's go pressed and low when low. And much like what you do in Android, we're just going to create an event listener. So whenever someone clicks this button or pushes this button, we want to do something, okay? So I end up with this, and I'm going to do pretty much the same thing we were doing before. So I'm just going to do a log here. And whenever we press the button now, I just want to show the GPIOs available. So service.GPIO list, and if I go ahead and run, I missed that. Oh yeah, very good. This was gonna error really badly. Thank you. So great. So this is gonna install now in a few seconds, and let me just zoom in here so you can see what's going on. Cool, so this should be installed. I am gonna leave these on the screen. Oh, I need to zoom out because, okay. So you can see, I believe you can see here, what needs to happen here right now is every single time I push this button, I should see a message at the bottom. So let's try that out. Okay. So, yeah. Thank you. Great. So this is the very beginning of everything, okay? You're going to be playing with buttons, you're going to be flashing some LEDs. It's going to get exciting. Back to the slides. Cool. So again, back up. And yeah, it's a video. It will show my finger in a second doing its thing. Cool, same thing. But what have you just seen? So this is the code I have just written right now, okay? So like I said, it's some Kotlin code, and there are two things I want you to pay attention on this. Those two things, the first one is, we've used Button, which is a contrib library. So this is a library that you, all of you, have access to change. You can send pull requests to it, you can add functionality to it. So most of the libraries that are internal to Android things are just accessible by anyone. You can make pull requests, you can create new libraries, it's up to you. So if there's a piece of hardware you want to use and there's no library for it, you can just create a library. Now the second bit is, oh, I actually said it the other way. So the first one is the internal library. Let me go back. First one is the internal library. The second one is the contrib library. So the internal libraries are the libraries you can't change. So this is like Android things core. The second one are the things you can change. The second one are the things you can go and create or send pull requests. This is all on GitHub. Okay, so everything is on GitHub. Libraries. There's a bunch of libraries for you to choose from. There's libraries for things like speakers, if you want to do speakers. There's libraries for if you want to have some external displays, for example. There's libraries for that. There's libraries for GPS. If you want to have a GPS in your device, you can use those libraries. But the most incredible thing about this is the thing that actually excites me the most, is you can create your own libraries. You can just say, hey, I want to use this hardware that no one is using, and I want to create my own library. So there are blog posts like this that actually show you how to create a library. If you were on the talk before mine, the speaker was actually talking about creating libraries for Android. It's the same process, all the same process. In fact, what I did myself was, there was this thing here which I wanted to use, and I found a library, but it didn't quite do exactly what I was looking for. It wasn't quite the same thing. So I just went ahead and I created a library for it. I wanted to use an LCD display, for example. There wasn't a library for that. I just went and created. So it's very easy for you to just go and create libraries for things that you need. And obviously you put it on GitHub and you share with the world. And now people can use that library as well, okay? So it's the same process of creating libraries for Android, but you're now interacting with hardware, which is really cool. Now, what is the landscape of Android things? This is the landscape of Android, okay? So you've got all these things in Android. You've got all these things which you kind of need to take care of, or you kind of need to think of. In Android things, you don't have many things. So you don't have a content provider, for example, because you don't need it. Like, Android things is meant to be an external piece of hardware. Like, you don't need things like access to contacts. You don't need access to, I don't know, camera on the device itself. You can add an external camera. So you don't need those things. And the nicest thing here as well is displays are optional. So far, we haven't used displays at all. Okay? Displays are completely optional. You are connected to this device just the same way as you're connected to any Android device. If you want to have a display, you can. So you can just get an HDMI connected to this. You can have a display. If you want to have like an external Raspberry Pi display, you can connect to this as well. So if you want to build an app that is a hybrid between hardware and just like have touch screen, for example, you can do it. Okay, so this is totally supported. If you don't have a screen, many people don't have a screen, no problem, because just like an Android device, you can use stuff like Visor, for example. So you don't need to have an external screen. With Visor, you can connect to your cool. Now another quick demo, and this one I'm going to tell you a bit of a backstory about it. The backstory about this one is I work from home and I listen to very loud music. I usually, because I'm listening to very loud music, I usually have my headphones on, which means I don't get any parcels. Like if I buy something from Amazon, for example, they're gonna knock on my door, they're gonna like ring my doorbell, and I'm not gonna hear it because I'm listening to music, and I'm like in the zone. And I see some people like nodding like, yeah, it happens to me too. So what I did was, there's this in front of me. So I miss parcels, but I don't miss calls. Like every time someone calls me, I'm looking at my phone, so I get the call and I answer it. Every time someone is at my door, I don't necessarily hear it. So what I built was an application that helps me getting a call on my phone. So instead of actually just trying to listen to the doorbell, I get a call on my phone, and it will say something to me to actually, to actually make me aware that there's someone at the door. So let's look at what this application is like. I'll stop this, and I'm gonna open a recent project, which is called Doorbell Things. Again, there's a blog post about this. It's on my GitHub, so it's all there for you. And what I have here is I have a server. I have a server function that basically uses my Twilio account. I know I said before I work for Twilio, so it basically uses my Twilio account to make a call, and it's going to make a call to my own phone. Now, if you look at my code, I'm not doing anything that you haven't done before, like I'm using retrofit, for example. So all the libraries that you can use in Android, you can use here. So I'm using retrofit to make a request to this. I have my doorbell class here, which is basically, how retrofit works. I've got an interface for that. And I'm checking, okay, and this one is in Java. So I know I showed the other ones in Kotlin. This one is in Java, so you can use anything you want to use, really. And so I have a button, I have an on button event here, so whenever someone presses that button, I want to get a call on my phone, okay? So we're going to try this now. Hopefully it's going to work. So this is the one I'm most concerned about, but we're going to see what happens. My device. I'm going to get my phone and I'm going to bring it closer here to the mic so you can actually hear it. And as soon as it installs, cool. So it's installed now. Let me open the thing here. And you see button pressed, and hopefully I'm going to get a call. So if that doesn't work, it's in. Oh, here we go. So I'm going to answer that, and I'm going to put it on loudspeaker.
There's somebody at the door.
Could you hear that? Okay. So what this says is there's someone at the door. Right, so it doesn't do anything special. All it does is it tells me there's someone at the door. So I get a call and it tells me there's someone at the door. And it's great because now I don't miss my parcels anymore. So this is one I kind of, because the other ones are like, they're simple applications. This one is like, it's actually very helpful. Like this is really useful to me. Quickly, back to my slides. I know we don't have much time. So Android Things is basically the power of Android. It's managed by Google, so there's a console, there's an IoT console that you can use to push over-the-air applications into your device, so you don't always need to have them connected. You can do over-the-air push, and it's automatic and secure, because obviously everything is going through Google, and they're trying to solve the problem with security in IoT. With that, I've been Marcos Placona. I work for Twilio. This is my information. I'll be around, so if you have any questions, just come and talk to me. Thank you very much.
Thank you, Marcos. It was really, really interesting. And if there are any questions, there are the microphones there. If you want to ask them, he's here still for some minutes. So make a question if you want to.
I'll be around too if you want to talk to me.
Hi. I was wondering about the boot time for the Raspberry Pi running the OS of Android.
Did you say boot time?
Yeah, the time it takes to boot.
Oh yeah, it takes like 20 seconds.
20 seconds.
Yeah, it's not massively fast, okay? With some of the other things I showed, some of the Picos, for example, they're faster. Like you can get to like 5 seconds or so. It's not massively fast, but yeah, it's about 20 seconds. It's gonna, if it's got like, if you need to connect to Wi-Fi, for example, then in those 20 seconds you will be able to do all that.
And what about the power consumption? Have you tried to use it connected to
that I had hooked up to this? I had an external, this was a 10,000 milliamp charger, and it lasted for about 3.5 days. So it's not, I'm not saying power consumption on this is great, okay? If you go to the other boards, it's better, because the Raspberry Pi is a very complete thing. You have a lot of things in it, whereas if you go to the other boards, you can just get the bits that you need. So, yeah, I usually tell people to power on the mains instead.
And what about when it's when it's on and running? So it's tied to just one single app that is running on it, or there's a way to switch between apps and
did, but what's going to happen is, if you shut it down and you turn it on again, the first app that you installed is the one that is going to come up. So it's meant to be used with one app only, not multiple apps.
Right. Thanks.
Do we have time still?
My question would be, how would you deploy this to like hundreds or thousands of devices? Like
Yeah, so
it needs to be connected to Wi-Fi, right?
So deploying to hundreds of thousands of devices, yes, you will need to be connected to Wi-Fi, and you can use the over-the-air deployment. So you don't need to actually be close to it. You can do over-the-air deployment using the IoT console.
But how do you connect to Wi-Fi?
So I can't.
Like ADB, something connect to this Wi-Fi with this password.
For the initial setup, yeah.
Yes, but can you like hard code that into that image file?
You can hard code it on the Raspberry Pi. Yes, you can do that. So you will need to make changes not on the Raspberry Pi itself. You need to make changes on the image, which is on the memory card. Then you can do that. It's slightly trickier than just doing it via ADB. But that's like a limitation to, not to Android things, it's a limitation to how the Raspberry Pi actually works. But you can do that. Yeah, it's possible to do it. Not as easy, though.
Yeah, okay.
Hello, so thanks for the talk, it was amazing.
Thank you.
I had a couple of questions. The first one is it possible to have services in your Android app, like if you want to have something running in background, because basically you showed you have an activity, can you have a small service?
No. No, you can't use services on it. That's the quick answer. You can't use services on it. You need to have an app running, and you can't.
And is there any limitation in terms of APK size or stuff like that that we should know about when you want to make something?
I don't know the answer to that. I don't know. I have not found any limitations yet, but I haven't built like gigantic applications yet. I'm not sure. I'll find out though, because it's something that is going to bug me now, so I'll find out.
Thank you very much.
You're welcome.
Thank you very much for your attention. Another presentation will begin shortly.